Some of you mentioned that you were having difficulty with the questions in lesson 17, especially the application type problems. And so I'm going to work through some of those examples or through some of the problems in the Newton homework to help you out. One of the things about these particular problems is usually the formula that you need is going to be given to you in the problem. So if I read through this problem, it says an account earned interest of 3% per year. The beginning balance was $150. The equation T equals log base 1.03 of E divided by 150 represents the situation where T is the time in years and E is the ending balance. If the account was open for 8 years, what was the ending balance? So again, as I'm looking at this particular problem, I notice that in the reading, and my eyes kind of go to that particular thing right off, is that I'm given the formula that I need, which is T equals the log of base 1.03 of E divided by 150. And again, one of the things that I would do in an application problem is I want to try to identify the pieces of information that I'm given in the problem. And in this problem, hopefully I'm either given the value of T, which if you read the problem, represents time in years, and E is your ending balance. Okay, so if I keep reading, the question itself says, if the account was open for 8 years. Okay, notice it has the years, and so that represents my time. And the question is, what was the ending balance? So I'm looking for the ending balance in the account. Okay, so then I'm going to do a substitution into the formula. So I would have 8 equals the log of base 1.03 of E to the 150. And I'm ultimately trying to solve for E, which means I ultimately want to get the E by itself. And to do that, I need to eliminate, okay, the log. The inverse function of a logarithm is an exponential of the same base. Well, the base here is 1.03. So I'm going to use a base of 1.03, and then I'm going to raise to the 8th power base of 1.03 and log of base 1.03 of E divided by 150. Basically, I've raised each side. I used a base of 1.83 as my base of the exponential function, and then the expressions itself becomes the actual exponents. So I have 1.03 to the 8th equals an exponential with a base of 1.03 and a logarithm with a base of 1.03 are inverses, and they will cancel one another off just like addition and subtraction. So I'm left with E divided by 150. Now, there's a variety of ways you can do this. I would probably go ahead and do the calculation. So I would have 1.03 raised to the 8th power, and you get 1.26677. Okay, so we get 1.26677, and that equals E divided by 150. I'm attempting to solve for E, so then I need to undo the division by 150, which I accomplish by multiplying both sides of the problem by 150. Well, I already have the value in my calculator's brain, so I'm going to multiply it times 150 which gives me 190.02. Okay, 190.02 would be the value of my ending balance. Now, let me go back up here and look and make sure I follow the instructions. It says, what was the ending balance? It doesn't indicate if it wants me to round to the nearest dollar or to the nearest cent. So you'd have to pay attention to the instructions. But ultimately, you should have to the nearest cent $190.02. If you go to the closest whole number or whole dollar amount, would be $190. Okay, moving on to the second example. It says the magnitude of an earthquake is represented by the equation, and it gives you the equation. M equals 23 times the log of E divided by E sub 0, where E is the amount of energy released by the earthquake in joules, and E sub 0 is 10 raised to the 4.4. Okay, I got a little typo there. Let me get that put in there as an exponent. Okay, 4.4 is the assigned minimal measure released by an earthquake. In scientific notation, okay, so that's kind of tricky. To the nearest tenth, what is the amount of energy released by an earthquake with a magnitude of 5.5? Okay, so as I'm looking at this, okay, again, I'm given the formula, so I have M equals 23 times the log of E divided by E sub 0. And again, one of the first things that I want to do is try to identify the pieces of information that are given. Okay, so M represents the magnitude. E is the energy released. And E sub 0 is the minimum energy that gets released. So if I go back through and I read through the problem again, it says E sub 0 is 10.4, 10 raised to the 4.4. So I have 10 raised to the 4.4 power. It says, what is the amount of energy released by the earthquake with a magnitude? Okay, so the very last thing it does in the magnitude is give me, or in the last sentence is give me the magnitude. So I have the magnitude and I have the minimum energy released. So then I'm going to substitute that information into the formula. So I have 5.5 equals 23 times the log of E divided by 10 to the 4.4. All I did was substitute the numbers into the formula that I was given in place of that particular variable. Now again, I'm trying to solve for, in this case, E, and the first thing I notice is that my logarithm is multiplied by 23. It's 23 times the log. So I want to get rid of that multiplication by 23. We undo multiplication by division. So I'm going to divide, pull up my calculator, and I'm going to divide 5.5 divided by 23. And that gives me a value of 0.2391. And again, it's best to carry all the decimals with you. So 304 equals the division by 23. I'm left with log of E raised E divided by 10 to the 4.4. Then I need to eliminate or get rid of the logarithm. It is a log with an understood base of 10, so I'm going to have to raise each side to the 10th. So I'm going to do 10 raised to the 2.391, so forth. Let me get a different color here so you can hopefully see the difference. So we're going to do 10 raised to the 0.2391304,348 equals 10 raised to the log of e to the 10.4. Okay. So on the left side, I want to do 10 raised to that decimal exponent, which is in my calculator's brain. So I'm just going to pull it in. And I get 1.7343 24 equals, on the right side, exponential of base 10, logarithm of base 10. So we have e divided by 10 raised to the 4.4 power. Last thing, I'm trying to isolate the e, so the next thing that I want to do is multiply both sides by 10 to the 4.4 power. So when I do that, I have the answer in my calculator. I want to do that times 10 raised to the 4.4. And we enter. Okay, and we get 43,564. Now, the question said in scientific notation. So there's a couple of ways you can look at that, do that. Hopefully you might remember how to do that from memory to convert it to scientific notation. So we have 43,564. Okay, so we have 43,624 564, excuse me. All right, let me get this number written down correctly. 43564. Okay. 43564.2. Okay, so if I do that, that's actually in whole number form, and I need it in scientific notation. With scientific notation, you're going to move it so you have a number less than 1, or excuse me, between 0 and 1. So I'm going to move 1, 2, 3, 4 places, 5 places. So you'd have 4.3. I moved 1 place too many. Okay, so you put it between the 4 and the 3. 4.3 times 10, and then we think about how many places we moved. We moved 1, 2, 3, 4 places, and we moved left. So it should be to the negative 4. 4.3 times 10 to the negative 4. That's a little confusing. Now, on your calculator, you can, if you go to mode, you can ask it to see the first line. It says normal, sci, or ENG. We want it in scientific, so I could arrow over to scientific. Then I have to quit. And if I hit enter, it automatically converts that particular problem to scientific notation. Okay? Incorrectly, I think, but it does convert it. Okay, so this is your answer. All right, one more. Hopefully this is not too confusing. says the wind speed near the center of a tornado is represented by the equation S equals 93 log of D plus 65, where D is the distance in miles that the tornado travels, and S is the wind speed in miles per hour. If the wind speed, which would be S, was 150 miles per hour, how many miles did the tornado travel? So again, in this problem, they've given you the formula S equals 93 log of D plus 65. They tell us that S is our wind speed and that D is the distance that the tornado travels in miles. Okay, so then it tells us that our wind speed is 150. So we would have 150 equals 93 times the log of D plus 65. And our ultimate goal is to solve for D. So we got to do some basic algebra. I need to subtract 65 from either side. So that's good old basic math. 150 minus 65. Let me put it back in normal mode. 150 minus 65 equals 85. So we have 85 equals 93 times the log of D. Then I need to get rid of the multiplication by 93. So I'm going to divide both sides by 93. Okay, so I have 85 divided by 93 equals log of D. Okay, then we need to get rid of the log, which is a base 10. So I'm going to use an exponential of base 10. I'm going to raise each side. So I have 10 raised to the 85 divided by 93 power equals 10 raised to the log of D. So I'm going to get my calculator. Okay, I can type that in at one time. Okay, I'm going to do 10 raised, and in parentheses, I'm going to put 85 divided by 93. Okay, and that gives me 8.203. 8.203, and that equals my log and my exponential base 10 are going to cancel one another off. They're inverses, and that's going to equal D. Okay, so the distance traveled by the tornado would be roughly 8 miles, or 8.2 miles. Okay, so there's some examples of the applications in Lesson 19. Hopefully, if you're having calculator issues, this will help to clear it up.